continuously, because this voltage is depending upon time. See here, this time is 1 second, 2 second, 3 second, 4 second, changing. So that is why this voltage is also changing. Hello Nawal.
Hello, sir.
Hello, how are
I'm fine, sir.
you? Hello Matthew. Matthew, am I audible?
Yes, sir. Good
Okay,
evening.
good evening. And how are you?
I'm fine, sir.
So we will do a quick revision. Okay, we will do a quick revision. Basically, here what we are studying in this chapter, alternating current and alternating voltage, means the current which changes with time is alternating current, the voltage which changes with time, alternating voltage. Okay, and I have told you what is the equation of the alternating voltage. First I have told you the equation of the alternating voltage. I have told you, right, the equation of the alternating EMF or voltage will be E is equal to E naught sin omega t. What is E? E is the instantaneous value of the EMF. Instantaneous. Instantaneous means the value of EMF at any particular instant of time. What is E naught? E naught is the peak value. E naught is the peak value or the maximum value of the EMF. Okay. What is omega? Omega is the angular frequency. Omega is angular frequency. And T is the time. T is the time. And equation of the current is also in this form. Equation of the current, I is equal to I naught sin omega t, in this form. Okay, plus phi. You can, if there is a phase difference, then we will take phi. Otherwise, this will be I is equal to I naught sin omega t. So what is I naught? I naught again is the peak value of the alternating current. Omega is the angular frequency of the current. I is the instantaneous current. What is T? T is the time. Okay, so this is the equation of the current, alternating current. Okay, so here now what is happening? We know that this is time, and time is continuously changing. 1 second, 2 second, and 3 second. Like, time is continuously changing. So with time, the EMF will also change, because this EMF is a function of the time. Okay, this EMF is a function of the time. If time will change with respect to that time, the EMF will change. And we have seen that the graph of the EMF with time. If we draw the graph of EMF with time to see how the EMF is changing, so we will get this type of graph. This type of graph. Here the direction of the EMF in upward direction, downward direction, along positive, along negative direction. Okay, here the value of the EMF becomes 0. At this point, the value of the EMF become maximum. So basically what I want to say, the alternating EMF changes with time in direction as well as in magnitude. Okay, so we have discussed purely resistive circuit. We have discussed purely resistive circuit. What is the meaning of the purely resistive circuit? You are connecting only a resistor with an alternating voltage source. With an alternating voltage source. So there I have written the equation of the voltage V is equal to V naught sin omega t. Okay. Earlier I have written E for EMF. Now I am written for V. V is for voltage. Okay. Basically both are the same thing. Okay. EMF and the voltage. EMF is the basically the maximum voltage. Okay. So in circuit we represent the voltage generally. So what is V? V is equal to V naught sin omega t. This is the equation of the voltage. I is equal to I naught sin omega t. What is omega t here? Here your omega t will be the phase of the voltage. Omega t is the phase of the voltage, and omega t also the phase of the current. Here the phase of the voltage and the current is same. That is why the phase difference is 0. That is why current and the voltage are in same phase. Current and voltage are in same phase. So there is only resistance in the circuit. then if you want to find the peak value of the current in the purely resistive circuit, and what is the value of the current? Current is equal to voltage divided by the resistance. So peak value of the current is equal to peak value of the voltage divided by the resistance. In case of purely inductive circuit, I have written the value of the voltage V is equal to V naught sine omega t, but the current equation will change. I is equal to I naught sine omega t minus pi by 2. Minus pi by 2 means this is the phase of the voltage. This is the phase of the current. So you can see the phase of the current is less than the phase of the voltage. So you can say the current is lagging behind the voltage by 90 degree. Pi by 2 means 90 degree. And there is here another term, inductive reactance. Here is another term, inductive reactance, and inductive reactance is given by omega into L. What is L? L is the inductance. Omega is the angular frequency. Omega is also given by 2 pi f. Okay. In case of pure inductive circuit, if you want to calculate the peak value of the current, and I have told you this inductive reactance is just like the resistance, in inductive circuit, and its unit is also the ohm, like of resistance. So basically, in purely inductive circuit, if you want to find the current, what is the mean? What is current? Current is equal to voltage divided by the resistance. So peak current in the purely inductive circuit is equal to V naught divided by XL. XL you can say here a type of resistance. Okay, XL is basically capacitive reactance. Basically a capacitive reactance. Now for purely capacitive circuit means only capacitor will be connected with an alternating source of voltage. So what is the equation of the voltage? V is equal to V naught sine omega t. Okay, here the equation of the current will be I is equal to I naught sine omega t plus pi by 2. Here the phase of the current is more than the phase of the voltage, means current is leading the voltage by 90 degree or pi by 2. Here is another type of reactance, capacitive reactance. Capacitive reactance is given by 1 upon omega c. What is C? C is the capacitance of the capacitor. In this case, if you want to find the peak value of the current, then you will write V naught divided by Xc. So basically, this circuit today we will discuss series LCR circuit. Series LCR circuit we will discuss. Series LCR circuit means there will be one inductor, there will be one capacitor, there will be one resistor connected in series with an alternating source, with an alternating voltage source. So basically, already we have completed this part. This is just the revision. Now I am starting the series LCR circuit. So see the equation of the voltage and see the equation of the current. Series LCR circuit. Series LCR circuit means we are connecting in series inductor, capacitor, and resistor. So inductor is, there is one inductor, there is one capacitor, and there is one resistor connected, and this is an alternating voltage source. So suppose at any time t, the voltage of this source is V bracket t. V bracket t is representing the voltage is a function of time. Voltage is a function of time, okay? Because voltage I have told you is changing with time. Voltage is a function of time. Suppose at any instant of time, the direction and the equation of the current is I is equal to I naught sine omega t. I is equal to I naught sine omega t. And for that instant, suppose V suffix L is the voltage across the inductor, V suffix R is the voltage across the resistance, V suffix C is the voltage across the capacitor. Okay. So already know these equations. If current is this in the circuit, and current will be same throughout the circuit, across the inductor also the current will be same, across the capacitor the current will be same, across the resistance the current will be same, because this is a series circuit. So in series the current remains same. Okay, so what will be the equation of the voltage for resistance? V voltage across the resistance at any time t is equal to the peak voltage across the resistance sine omega t. Why? Because phase difference between the current and the voltage for the resistance is zero, already discussed. Okay, if you want to find the peak value of the current, I have told you how to find peak value of the resistance divided by the resistance. So this thing we can write. Now for the inductor, the equation of the voltage for the inductor will be V is equal to peak value of the voltage across the inductor sine omega t plus pi by 2. For the capacitor, peak value of the voltage sine omega t minus pi by 2. Already discussed. And this thing we know already. What is xc? Xc is 1 upon omega c. Okay, now we will draw the phasor diagram. We will draw the phasor diagram of this circuit. Phasor diagram. So phasor diagram we will draw with the help of equation of current, equation of this voltage across the resistance, and voltage across the capacitor and inductor. Basically, we will draw the phasor diagram with the help of the equation of the current and the voltage. So okay. So this is the current. I is equal to I naught sine omega t. Phase of the current is omega t. Phase of the current is omega t. So suppose current I am taking, this is the current direction on, okay, this is current, this is the current. Now voltage across the resistance, the phase of voltage across the resistance will also omega t. So in this direction the voltage also will be there, because current and the voltage are in same phase for case of the resistance. So we can write this will be the voltage, peak voltage across the resistance. And I have told you the length of the arrow will give you the peak value of the voltage. The length of the arrow will give you the peak value of the voltage. Now this is the current. This is the current. Now for inductor, phase of the current is omega t. Phase of the current is omega t. For inductor C, phase of the voltage is omega t plus pi by 2. Means in case of the inductor, the voltage leads the current by pi by 2. So this will be the voltage across the inductor and leads the current by pi by 2. This is the current and this is the peak value of the voltage across the inductor. See the equation of the voltage across the capacitor. See the phase omega t minus pi by 2 means the voltage in case of capacitor is lagging behind the current by 90 degrees. Means here we will draw it like this. This will be peak value of the voltage across the capacitor. Peak value of the voltage across the capacitor. If I want to write this V naught across R can be written as I naught into R. V naught across L can be written as I naught into XL. V naught across C can be written as I naught into XC. Means the peak value of the current in the circuit is same. Okay. So this phasor is for the voltages. For the resistance and inductance, we can draw another phasor diagram. Another phasor diagram we can draw. And this phasor diagram is very, very important. Okay, now in terms of the resistance and capacitive reactance and inductive reactance, we will draw the phasor diagram. So current is this direction. So resistance also we can take in this direction. Like this we can write for the resistance, because current and the resistance. Okay, because this is V naught R, na? This is V naught R, and this V naught R is proportional to the resistance. So we can draw the graph with resistance, and here will be, see, this is V naught into L, so this is I naught, so we can write here XL. Okay, XL. Here is V naught C, here is V naught C, so I naught into XC. So here we can write XC. Basically, remember, this length of the arrow is representing V naught R, means the length of the arrow is equal to V naught R. Length of this arrow is V naught L. Length of this arrow is V naught C. Length of this arrow is XL. Basically, this is the length of this XL I have written now. This is the length of the arrow. This R I have written at the end. This is the length of this arrow. Please remember this point I have told you when first time I have told you the phasor diagram. The length of the arrow, okay, representing the quantity. Okay, so this is the phasor diagram. This angle will be 90 degree. This angle will also be 90 degree. Now, two things we will calculate from these two diagrams. We will calculate the resultant voltage. We will calculate the resultant voltage in this LCR circuit and the resultant resistance, and that is not known as the resistance, that is like resistance. Resultant impedance we say. Resultant impedance we say. Okay, so from this diagram, from first diagram, suppose this is the first diagram, this is the second phasor diagram. So from the first diagram, first we will see the voltage, okay, resultant voltage into how to calculate the resultant voltage with the help of this phasor diagram. Okay, so see this diagram. So I will talk about the three cases. I will talk about three cases. Number one, when peak value of the voltage across the inductor becomes greater than the peak value of the voltage across the capacitor. Or you can say XL greater than XC. How you can say? Because V naught L is given by I naught into XL. This will be greater than I naught into XC. So I naught gone. So you can write that XL can be greater than XC. Okay. So that is why this condition and this condition is the same condition. Okay. Now see this diagram. They are saying this V naught L and this is greater than this V naught C. This is looking like two vectors acting in opposite direction. This V naught L and V naught C is looking like two vectors are acting in opposite direction. We can get the resultant. Okay. If two vectors are acting at 180-degree angle, what is the resultant? A minus B. For example, if you have two vectors, suppose this is your A vector, this is your B vector, suppose acting at some point. Suppose the magnitude of A is greater than magnitude of B, and you want to find the resultant, then how you will find A minus B? A minus B will be the resultant. Basically, they are saying V naught L is greater than V naught C. So we can write this is V naught L minus V naught C. This will be the resultant voltage along this. Okay, resultant voltage along this. Okay. Okay. What is the resultant voltage along this? V naught L minus V naught C. Basically, this is V naught C, not L. Because here is C, na? This is V naught C. Okay, tell me one thing. When you have two vectors, suppose this is your A vector, this is your B vectors. Two vectors are acting at 90-degree angle. Then resultant of these vectors is given by r is equal to under root of a square plus b square plus 2ab cos 90, and cos 90 is 0. So resultant you will get as a square plus b square, a square plus b square. So basically in this case we can apply this also, but these are not the vector quantities. Okay, these are not the vector quantities, but this will be valid here. This thing will be valid here. Okay, so I am telling this with different method. Okay, till then note down this. Nafisa, are you getting?
Yes, sir.
Matthew and Nawal?
Yes, sir.
Yes, sir.
Here I have represented V naught L as the peak value of the voltage across the resistance, peak value of the voltage across the inductor, peak value of the voltage across the capacitor.
Done.
Okay. Completed, Nafisa?
Yes, sir.
Okay.
Yes, sir. Finish.
Okay. So now see, one voltage in this direction, one voltage in this direction. We want to find the resultant voltage. Okay, so what we will do, we will draw a parallel line like this. Parallel line means which parallel line? Parallel to this. Okay, parallel to this, a line we will draw, and we will draw a line parallel to this. Okay, where these both the line will intersect. Basically, this thing will be the resultant voltage, that is V naught. This thing will be the resultant voltage. This is will be V naught. So how we will find this V naught? I have told you this length is equal to this V naught minus V naught this, okay? V naught L minus V naught C, this length. So this is a rectangle, na? This is a rectangle, means this side becomes equal to this side. So this will be V naught of L minus V naught of C. Okay, and this distance is, I have told you, will be V naught R, V naught of R, and this becomes a right angle triangle. With this becomes a right angle triangle. This becomes a right angle triangle. So consider the point. Suppose this is point O, this is point A, and this is point B. So now see in triangle OAB. See in triangle OAB. Can we apply the Pythagoras theorem? Can we apply the Pythagoras theorem? So when you will apply the Pythagoras theorem, so opposite to 90 degree, this will be hypotenuse. This will be perpendicular of the triangle V naught minus VL, means AB length will be, see here, your OA length is equal to V naught that you want to find. Your OB length is equal to V naught R. Your AB length of the triangle will be V naught L minus V naught C. Okay, this will be V naught C. This will be V naught C. Now when you will apply the Pythagoras theorem, so hypotenuse square is equal to perpendicular square, or you can say hypotenuse square is equal to base square plus perpendicular square. So we can write here V naught square is equal to V naught R square plus V naught L minus V naught C square. So you calculate, this is V naught square, and V naught square R can be written as I naught into R. This V naught R can be written as I naught into R plus, basically this will be the whole square of V naught L minus V naught C. This will be the whole square here. Okay, so you can write this V naught L as I naught into XL minus I naught into XC and square, and this is also the square. Now this is V naught square, and I naught square you can take common. So this will be I naught square, and here you will have R square plus I naught will be common, and out of this square it will become I square. So we will take it common. So it will become XL minus XC square. XL minus XC square. Okay. So for finding the V naught, we will take the under root. That will be equal to here outside this will be I naught, and this will be R square plus XL minus XC square, and this term is known as Z. This R square plus XL minus XC square is known as Z. This term is known as the Z, and this Z is known as the impedance of the circuit. Z is known as the impedance. Z is the impedance. Impedance. So resultant voltage is this. V naught is equal to I naught into this. Okay. So resultant voltage, you can write resultant voltage in the circuit is equal to peak value of the current into the impedance Z. So this will be the resultant voltage. So this formula, both these formula you should. Okay, so this diagram I will use now. So here in this case, XL is greater than XC. So we can modify this diagram. We can write here XL minus XC. So this is the case now, like we have calculated the resultant voltage. Okay. So here the resultant, this is the resistance. In this direction, this is the difference of capacitive reactance and inductive reactance. So resultant will be the impedance. So resultant will be the impedance Z. And Z we have already calculated. Z we have already calculated. What is the value of the Z? R square plus XL minus XC square. Okay. XL minus XC square, and here this angle is phi. This angle will be phi. Phase difference between the current and the voltage. This is the direction of the current I have told you. So phi is the phase difference between the current and the voltage. What is phi here? Phi is the phase difference. Phi is the phase difference between the current and the voltage. Phi is the phase difference between current and voltage. Current and voltage. Phi is the phase difference between the current and the voltage. Okay. From this, we can calculate one more thing. If we complete the triangle like earlier we have completed, so this value will be XL minus XC, and this will be phi. Phi is the phase difference, and this is the resistance R. So from here, first thing we can find the power factor. What is power factor? Power factor is basically cos phi. Cos phi is the power factor. Cos phi, when you will find from here, it will become R by Z, because this is Z. This distance is Z now. So cos phi is equal to R by Z. There is one more thing you can find, tan phi. Tan phi is perpendicular divided by base. Perpendicular is XL minus XC divided by R. So this will be XL minus XC divided by R. Okay. Now case number second. Case number second we will discuss. When voltage across peak voltage across the capacitor becomes greater than the peak voltage across the inductor, or you can say XC becomes greater than XL. Now what was the phasor diagram for the voltage? This was the phasor diagram. Now this time this V naught C is greater. This time this V naught C is greater, so we can modify this diagram. So we can, this V naught C is greater, na? So we can modify this diagram and we can write this will be the diagram, and there will be a slight modification here. Here we can write this is V naught C minus of V naught of L. Okay, V naught of L. So this will be the phasor diagram. And what is this V naught L minus V naught C minus V naught L? This will be the length of this arrow. What is V naught R? Length of this arrow. Okay, remember this point. So if you want to find the resultant voltage, again you will get like this. This will be the resultant voltage. That is V naught. What will be the value of the V naught again? You can find it with the help of the triangle that I have told you here. V naught is equal to under root of V naught R square plus V naught of C minus V naught of L square. Okay. And from here also you will get V naught is equal to I naught into under root of, when you will solve it, then you will get I naught into R square plus XC minus XL square. This time you will get XC minus XL square you will get. Okay. So what is your impedance here? Z is equal to under root of R square plus XC minus XL square. Okay. So okay, so V naught, you can find V naught is equal to peak value of the current into Z. Okay, so this is the current, this is the current in the LCR circuit, and this is the resultant voltage in the LCR circuit. So suppose phi is the phase difference between the current and the voltage. Phi is the phase difference between the current and the voltage. Phi is the phase difference between the current and the voltage. Okay. So this diagram also we can modify, this phasor diagram. We are discussing this case. XC is greater than XL. So XC is greater than XL, so we can just modify it like so this will become XC minus XL. This will become XC minus XL. Resultant impedance, and this is the resultant. This is resultant reactance, and this is resistance. So for the resultant impedance, this will be the resultant impedance, that is Z. This is Z, okay, and this is making an angle phi. What is phi? Phi is the phase difference between the current and the voltage, okay. So from here we can find first power factor. That is cos phi is known as the power factor. So for the power factor, when you will complete the triangle, you will get xc minus xl divided by r. Xc minus xl divided by r. Second thing you can find from here tan phi. So when you will find tan phi from this, you will get tan phi is perpendicular divided by base. Sorry, cos phi you will get what is the meaning of the cos? Cos is base by hypotenuse, na? Cos will be base by hypotenuse. If you will complete this triangle, if you will complete this triangle, we have to increase the length. Suppose this is the once again I am explaining. You have completed this triangle, okay? This triangle you have completed. And this length is Z. This length is Z, eh? And this length is XL, XC minus XL, XC minus XL, okay? If you will complete this, XC minus XL, now find cos phi. Cos phi, this is a right angle triangle now. This is a right angle triangle now. See here, basically this is also known as the impedance triangle. So in this triangle, how you will find the cos phi? Cos phi is base by hypotenuse. So base is this R. Base is this R. Hypotenuse is Z. So R by Z will be your cos phi. If you want to find it, tan phi is perpendicular divided by hypotenuse. What is perpendicular in this triangle? XC minus XL. Base is R. So XC minus XL divided by R. XC minus XL divided by R will be your tan phi in this case. Okay. So if in this case, finally you want to write the equation of the current, what is the equation of the current? I is equal to I naught sine omega t, and equation of the voltage we have V is equal to V naught sine omega t plus phi. V is equal to V naught sine omega t plus phi. See, phi is the phase difference between the current and the voltage. Or in this case, if you want to write the equation of the current and the voltage, in this case, here phi is the phase difference between the current and the resultant voltage. So equation of the current I is equal to I naught sine of omega t, and equation of the voltage V is equal to V naught sine of omega t plus phi. Phi is the phase difference between the current and the voltage. Phase difference can be 30 degree, 45 degree, 60 degree. Okay, so there is one last case also. Case number 3rd. Basically, this case number 3rd we will discuss in detail. Basically, this is a condition of resonance. This is a condition of resonance when your XL is equal to XC. When your XL is equal to XC, or in magnitude, I am talking when your voltage across the inductor, peak value of the voltage across the inductor becomes equal to the peak value of the voltage across the capacitor. So in this case, the resultant diagram of current and the voltage will be this. This will be the voltage and this will be the current. What happens now? See, what was the diagram? Initially, phasor diagram for the voltage. This was the diagram now. So here, see, V naught L and V naught C are equal, so both will be cancel out. Both will be cancel out. This will also be cancel out. So finally, what we will get? Finally, what we will get? We will get only V naught of R. Okay, and here will be the current. Same will be the case for the uh, same will be the case for this diagram. This XC and XL will be cancelled out, so here will be only I and R. So this type of diagram you will get here. Here will be the current like this. Here will be the current like this, I and R you will get. So here the resultant voltage of the circuit will become V naught R. Here the resultant impedance of the circuit will become R. You can use this formula also for calculating Z is equal to R square plus XL minus XC square, or you can write XC minus XL square also, because this is a square, so there is no difference between XL minus XC square or XC minus XL square. So here you see XL is equal to XC, so this term will become 0. So here will be R square, so that is why I have written Z is equal to R. Same you can do for the voltage. You will write V is equal to V naught across R square plus V naught L minus V naught C square, and V naught L and V naught C are equal, both are cancel out. Finally you will get this will be the resultant voltage. So basically what will be the equation of the current here? Equation of the current in this case will be I is equal to I naught sine omega t. Equation of the current is same because initially I have assumed the current I is equal to I naught sine omega t. Okay. Now equation of the voltage. How we will write the equation of the, see, resultant voltage, this is the resultant voltage. Okay, this is the resultant voltage and the current are in same phase. So equation of the voltage will also be like this: V is equal to V naught sine omega t. Why this? Because both voltage and the current are in same phase, then this will be the condition. Basically this is the condition of the resonance. Resonance is a separate topic, we will discuss this topic in detail. Okay, write down. And please have patience. When you will revise it 1 or 2 times, you will get it properly. Matthew,
Yes, sir.
getting,
Yes, sir.
and Nawal,
Yes, sir.
and Nafisa.
Yes, sir.
Scroll down. Completed.
Wait.
Okay. This is voltage. Completed.
Yes, sir.
Yeah, sir.
Okay. Don't think this is I have done something very extraordinary. Okay, I have just used this triangle. This is a right angle triangle, and I know this length is this, and I know this length is this. Anyone, even 10th class student can calculate what is cos phi, what is tan phi. Okay, so this is looking like very complicated, but this is very easy. This chapter is very easy. as compared to the magnet and as compared to the electromagnetic induction? Basically, this alternating current, you can say, is a whole uh, chapter in detail, or in electrical engineering. In electrical engineering, this thing, this diagrams and all these concepts of this uh, studied there. So this is just the introduction of the alternating current here. I know because I was in first year of my BTech, and second year of BTech, there is a subject basics of uh, electrical engineering. So there also we have studied this thing, but in very detailed manner. This is just the introduction, you can say. Scroll down.
Yeah.
Nafisa, scroll down.
Yes, sir.
Okay. Oh, sorry. Just wait a minute. Now, note down. Hmm. What I have written here, the equation of the voltage. Okay, we will improve that. Scroll down.
Yes, sir.
So basically, this is a phasor diagram for voltage, and this is a phasor diagram for the impedance. And here, basically, this here not be phi, it will be minus phi, because see here the voltage is lagging. See here the voltage is lagging the current, so the phase of the voltage will be less, minus phi. Write down. Power factor we will discuss again when we will derive the result of power in AC circuit. Again, I will discuss the power factor there. Remember, phi is the phase difference between the current and the voltage. Phi is the phase difference between the current and the voltage. Scroll down, Matthew.
Yes, sir.
Wait.
Okay.
Yeah, now.
Write down this last part. And after this, we will solve one numerical. And in that numerical, all the concepts will be included. Completed?
Yeah, sir.
Okay, so now all of you see the phasor diagrams. See the phasor diagram. See the equation of the voltages. Okay, we will solve one numerical. So all these things will be required there. Okay, so then after that you will say that you are not getting. But if you are not getting, the reason is that the basic things are not clear to you. Okay. See the phasor diagram. This is a phasor diagram of typical LER circuit. Okay, this is the, but see the phasor diagram. When voltage across the inductor is greater than the voltage across the capacitor, or XL, basically XL is greater than XC, then phasor diagram will be like this. Phasor diagram of the voltage will be like this, and phasor diagram of the impedance will be like this. Okay, and for XC is greater than XL, phasor diagram will be like this. Okay. So, and remember, peak value of the current, peak value of the voltage is given by I naught into Z. And what is the formula of the Z? Remember formula of the, there are so many things I know, but when you will revise, it will be fine. Okay. See this question. Okay, so one by one we will discuss basically inductor, capacitor, resistor. And what is this? An alternating voltage source. Current in this circuit at any instant of time is given by I is equal to 10 sine 100t. Current is given as 10 sine 100t. So current is given as 10 sine 100t. Okay. Capacitance this, resistance this, inductance this. First thing we have to find XL. First thing we have to find XL, then XC, then Z, and all these things we want to find. See, this is the equation of the current given. What is the equation of the current we know? I is equal to I naught sine omega t. Suppose this is your equation number 1. This is your equation number 2. Now compare the equation number 1 and equation number 2. Compare the equation number 1 and equation number 2. You will get the peak value of the current in the circuit as 10 ampere, and omega is equal to 100 radian per second you will get. Okay, this is I naught as 10, omega as 100. when you will compare both the equations. Now, first part, they are asking XL. What is the formula of XL? Omega into L. What is omega? 100. What is L? Check what is L. L is 0.16. Okay, so we will put here 0.16. We will get 16. What is the unit of XL? Ohm. Second, they are asking XC. XC is 1 upon omega C. What is omega? 100. What is C? It is given that 500 microfarad. 500 microfarad. 1 microfarad is equal to 10 to the power minus 6. So 500 microfarad can be written as 500 into 10 to the power minus 6 farad. So here we can write 500 into 10 to the power minus 6 farad. Okay, now how we will solve it? This is 10 to the power 6. This will be in the numerator. Okay, this will become 5 into 10 to the power 4. Okay, so I can write it as 10 into 10 to the power 5, and it can be written as 5 into 10 to the power 4. This 5 is cancelled with 2, and this 10 to the power 4, when you will cancel it out, you will get 10. So basically 2 into 10, you will get 20 ohm. So your XL is 16 and XC is 20 ohm. So what is the condition here? Your XC is greater than XL. This is the condition. So second part is also completed. Now Z, how to find Z? What is the formula of the Z? Simple. Resistance square plus XL minus XC square, or you can write XC minus XL square. So Z is equal to R square. What is the value of the R? 3 ohm is given. R is 3 ohm. So R is 3 ohm means 3 square. What is XL minus XC square? XL is 16, XC is 20 square. So it will be 3 square means 9, 16 minus 20 is 4, 4 is minus 4 square is 16, 16 plus 9, 25, root of 25 you will get 5 ohm. So Z is equal to 5 ohm you will get. Fourth part, phi. They are asking phi. One formula I have told you, tan phi, when your XC is greater than XL, tan phi becomes XC minus XL divided by R. What is your XC? 20. What is your XL? 16. What is your R? 3. 4 by 3. So tan phi is equal to 4 by 3. Tan phi is equal to 4 by 3. If you want, then you can write phi is equal to tan of inverse 4 by 3. But basically tan phi is, if it is written that, answer we got. Now I am telling one another thing. If it is written that tan phi or tan theta is equal to 4 by 3. What is tan? Tan is perpendicular divided by base. So there will be a triangle whose perpendicular will be 4 and whose base will be 3. This is a special type of triangle and having an angle of 53 degrees. Having an angle of 53 degrees. This is one special triangle, and another special triangle is that if there is a triangle having perpendicular 3, base 4, and this is the 5 we know. This angle will be 37 degrees. So basically tan phi is equal to 4 by 3. So what will be the value of the phi? From this triangle you can get the value of the phi as 53 degrees. So this answer is also correct. This answer is also correct. Okay. Phi we calculated. They are asking voltage in the circuit at any time t. Voltage in the circuit at any time t. Fourth. So voltage at any time t is given by V is equal to V naught sine of omega t minus 5. Why minus 5? Because here your xc is greater than xl, and what type of diagram you will get in this direction? Here will be v naught of r, here you will get v naught of c minus v naught of l, and resultant voltage will be like this. This is your v naught, this is phi, and direction of the current is this. So here your voltage is lagging. So that is why I have written omega t minus phi, and phi we know, omega we know, v naught we have to calculate. How to calculate v naught? V naught is equal to I naught into Z. What is I? How to calculate I naught? How to calculate I naught? Z we know, okay. And to calculate I naught, we know, we should know this. When we will compare this equation, I naught we have already calculated, that is 10 ampere, okay. I naught is 10 ampere. What is Z? Z is 5. So basically your V naught will be 50 volt, and omega we know 100. So equation of the voltage at any time t is equal to V naught is 50 sine omega is 100 t minus 53 degree. So this is the equation of the voltage at any time t. Fifth part. In fifth part they are asking, in sixth part, third, fourth, and this is fifth. This is fifth part. Sixth part they are asking voltage across the resistance. Voltage across the resistance. So voltage across the resistance. Okay. Voltage across the resistance with respect to time they are asking. What is the equation? V naught across the resistance sine omega t. Because phase difference between the voltage and the current will be zero. Phase difference between the voltage and the current will be zero in case of the resistance. So V naught R we can calculate. V naught R, I have told you how to calculate. It can be written as I naught into R. What is I naught is 10, R is I think 3. So it will be 30 volt. So this equation we can write VRT is equal to, or you can write VRT is equal to V naught R is 30, and this is sine omega is 100 into t. Sixth part. In sixth part, seventh part they are asking VLR, voltage across the inductor. This is fifth, this is sixth, first, second, third, fourth, fifth, sixth. Now it will be seventh. So they are asking voltage across the inductor with respect to time. So what will be the equation? V naught L sine omega t plus pi by 2. Sine omega t plus pi by 2. Okay. Sine omega t plus pi by 2 or 90 degree you can write. And write 90 degree also. What is V naught L? How to calculate V naught L? V naught L is given by I naught into XL. What is I naught? I naught I think is 10, XL is I think 16. So it will become 160 volt. Now we can write this equation VLT is equal to V naught L is 160 sine omega is 100t plus 90 degree. Eighth part, VCT is voltage across the capacitor. Eighth part. So voltage across the capacitor is given by V naught C sine omega t minus 90 degree. Okay, so V naught C can be find it out with I naught into XC sine omega t minus 90 degree. Okay, so what is I naught is 10. This is 10 and this is 20. This is sine and this is 100 t minus 90. Okay, so this will become 20 sine 100 t minus 90 degree. This is your voltage across the capacitor changing with time. Okay, so ninth part, power factor. Simple. I have told you how to calculate the power factor. Ninth. Power factor is cos phi. What is cos phi? I have told you R by Z. What is R? 3. Z is 5. This is your cos phi power factor. Now, 10th part, average power. This we will drive. Average power is given by VRMS, IRMS, cos phi. Okay, this is given by VRMS, IRMS into cos phi. Cos phi is the power factor. VRMS is given by V naught by root 2 and IRMS is given by I naught by root 2 and cos phi is R by Z. So it will become I naught V naught by 2, V naught I naught by 2 into R by Z. Okay. So what is V naught? See what is V naught? V naught is 50. V naught is 50. Okay. So right here V naught 50. What is I naught 10? This is 2. What is R by Z? 3 by 5. So see what will be the value you are getting. 5 tens are and 2 fives are. So you will get 150. Average power you will get 150 joule. Oh, not joule. Unit of power is watt. So 150 watt you will get. Okay, this will be your average power derivation. We will do in the next class. Okay, don't note down all of you. So all the concepts I have used here in this question. So I think 3 topics are left. One is the average power. I think 4. Average power in a AC circuit. Another is the resonance, and another is the transformer. 3 topics left. Matthew.
Yes, sir.
These days, you are not asking any doubt. Why?
Sir, no, I kind of learned this already in school, so that's what. So all the doubts are asked to the teacher. But yeah,
Okay.
yeah,
No
I'm just
one
trying to.
these days is no one these days no one is asking doubt. So I think that if doubt asking is stopped, so it means that the students are either studying very hard or they don't know. Either they don't know anything. Uh, there can be two reasons. So maybe your reason will be the first one. You are studying very hard.
No, sir,
And
it's more like we are currently doing this chapter. This is the one of
yeah,
the last
okay.
chapters we are doing.
Hmm.
So then, because of that, like at the same time, we are learning the tuition.
Yeah, okay, okay.
Because
Fine.
of that,
Very good. You can tell me when completed, okay? So scroll down. Nafisa, are you revising your notes of school and coaching?
Yes, sir.
And Nawal?
Yes, sir.
so you can scroll down.
Nafisa, scroll down.
Yes, sir.
Done, sir.
Nafisa, completed.
Yes, sir. Finished.
Nawal, completed.
Yes, sir.
Okay. So if you are studying physics now, so you have to apply your mind. This is the necessary condition. This is not chemistry. You can just learn the equation Mg plus SCl like this. It's not like this. There was a time when chemistry was my favorite subject, especially inorganic chemistry.
Done, sir.
Matthew,
Done, sir. Done.
completed, huh?
Yeah, just one last
I'm
step.
I'm asking one thing. There is one, I think, reagent. I don't know what is that. EDTA in inorganic chemistry. Ethylene di. I mean
Pyridine?
tetraacetate. EDTA.
Oh,
Ethylene
EDTA,
di.
yes, sir. Yeah.
I
It's a
remember that.
coordination compound.
Yeah. EDTA. Ethylene diamine tetraacetate. So, okay.